This is 2018 AMC 12B problem number 24, and here is a view of this problem. Let the floor of x denote the greatest integer less than or equal to x. That's the standard definition. How many real numbers x satisfy this given equation? We can directly start by rearranging the terms. In particular, this term on the left hand side, I want to bring it to the right hand side, so therefore it would give us x squared equals, and I realize that we have a 10,000 which is common in both terms, and finally so it should be x minus the floor of x. And it kind of gives you guys an idea of why I did that initially, because look at that, that's just the fractional part of the number, of the real number x. So therefore the equation reduces to solving this. And finally, one more time, let me go ahead and bring that 10,000 to the left hand side. So x squared over 10,000 is simply equal to the fractional part of x. Now, as you all know, the fractional part of x ranges from 0 to 1. It creates a piecewise function on the right hand side here, and on the left hand side we have a nice continuous function which is a parabola divided by 10,000. You might wonder when it hits 0 and 1 in particular. Obviously it hits it will accept the value of 0 when x is equal to 0, clearly, and when x is equal to plus or minus 100, the left hand side becomes 1. Does that make sense? So let's try to now graphically handle this question and try to see if we can solve it actually. So let me go ahead and draw my graph. So this is the x-axis. All the action will take place in this range between 0 and 1. So this is 0. This is the y-axis. Let me first go ahead and draw the fractional part. 1, 2, 3, and so on. So as you all remember, and maybe I need to go minus as well, so just give me a second here. So yeah, there you go, minus 1, minus 2, minus 3 as well. So when we draw the fractional part, we all know that it will be a function, so which starts here. Let's say this one is an open interval, then we jump back to 0, and then there we go all the way up to 1, and then start at 2, and so on. Does that make sense? We do trace this, and then we'll start at 3 again, and we'll go like that. And for negative numbers, pretty much the same thing. The largest integer less than our real number determines where the floor of that number would be, and so on. So there you go. So you have an open interval here. Now I need to, as I suggested, well, it turns out that when x is equal to plus or minus 100, we get that this whole expression, x squared over 10,000, is simply equal to 1. And that's exactly what I need. So let me go ahead and figure if I go further down all the way up to 100 to see what happens for the right hand side, and then how does it intersect with the left hand side. So so we have let's say this one is 98, 99, and maybe I need a little bit more space here, so let's just delete that. So we have, let's say this is 100. So and we need to do the same thing, so so we have, say, minus 98, minus 99, and maybe I need to go a bit further, minus 100, and finally, okay, let's say minus 101. All right, so when I extend the domain of this floor function, so it should be like that. Sorry, the fractional part of our numbers. Here, this one is empty again, and then finally we can keep going like that. And obviously the one before that was also, oops, not that one, sorry. I need to go back. Okay, there we go. So obviously this is an open interval, and then you can go back. All right, and we can obviously do the same thing for the negative end as well. So this is an open interval, closed here, open interval here, and so on. This is very standard drawing of the fractional part. Let's go ahead and now check this one. So we decided that this obviously will go through 0, 0. The function, we are talking about the function y equals x squared over 10,000. It will go to the point 0, 0 here, the origin, but it will further go through the points plus or minus 100 and 1 as well. So therefore it will hit the axis here. And so as a result, you are expecting it to be a parabola with, so obviously I don't know what happens in the middle here, so let me put 3 dots here. But I definitely know it will hit through here. And when you go in the negative direction, pretty much the same thing. It will hit through here, and I pretty much don't know what happens here. And let me just clean up a little bit here, this mess. Okay, so there you go. And now the question is just asking how many intersection points. That's quite a silly, easy question actually. So let's use probably black marker. So we just realized that this won't be an intersection point. No. Why is that? Because even though green one goes through that point 101, right? So 100 by 1, the red one jumps at that point, right? So because we have our fractional thing, never quite reaches the next integer. But this one is good, yes, and so on. So this one is good, obviously. So how do I count how many goods do we have? I can count it based on, let's say this piece, right? This piece hits the x-axis at 98, and so on. The previous one will hit at 97. Obviously, it will hit the 3 piece here. The 2 piece will be hit right here, and then the 1 piece. So all of these pieces are hit. Not quite all the way up to 99, up to 98. So I have 98 positive values. Does that make sense? And obviously, I have 0 for sure, plus 1. And then, because this is where the 2 intersect, and then I keep intersecting these this function multiple times until I exit the range 0, 1, right? This one is blank, so I'm not gonna count this one, no. But these are all good, right? So this is all good. This one is associated with minus 100. This point here is associated with minus 99. This one here is associated with minus 98. So if you count all these points, I can say there are 100 negative intersection points plus 0. And then we have 98 positive intersection points. So in total, we are expecting to have 199 real numbers x that satisfy the equation, and that solves our problem.